Today we'll create a somewhat realistic campfire in Blender. With an empty scene, create a plane and give it a displace modifier, set a noisy texture on it, and play with the settings to your liking. Just make sure the scale of the texture is large and not too grainy, as this is going to be the grass plane. Make sure to also apply smooth shading and then the modifier. Next, we'll set up a hair particle sim. Change it from an emitter to hair and increase the number of strands, shorten the length, enable hair dynamics, and play with the Brownian for some random rotation or curling. Under the Children tab, click on Simple and increase the amount number. This will make it look more like grass. Disable Viewport Display and give it a vertex group. We'll use some weight painting to control the density of grass along the plane, as well as make a clearing for the campfire. Once finished painting, enable Viewport Display. Under Vertex Groups, click on the Density tab and choose the vertex group you painted on. You can always paint more or less. Just remember to lower the amount of strands in the viewport display, as well as reduce the number of segments for better performance. For the rocks around the campfire, create a sphere, apply smoothing, and give it a displace modifier. You can use the same texture as the grass plane. For more randomness, set the displace modifier coordinates to global. This will change the displacement based on position, rotation, and scale. You can also slightly edit the geometry with proportional editing for more depth. Duplicate the sphere and place them around the center of the clearing. Once the rocks are set, create a cylinder, cut it in half, and add some edge loops. This will be the firewood. Enable smooth shading by angle, make sure the geometry is watertight, and correct transforms and origins. Give it some displacement with global coordinates similar to the rocks. Head over to the shading panel. Here we'll set up a simple, quick, and easy firewood material with a noise texture. Feel free to use custom textures for more realism. Simply create a noise texture with some mapping, play with the scale, feed it into a bump node which connects to the normal, add a color ramp from the noise texture, change the color tabs to wooden tones, and feed it into the base color. For custom roughness, use the same color ramp. Just remember to reset the saturation as it can only read black and white shades. Once happy, head back over to the layout panel and duplicate the firewood. Adjust each piece for more randomness. Selecting all pieces, apply all modifiers with one click with the Modifier Tools add-on. Finally, position all pieces central to the campfire with different heights and rotation. Apply all transforms and reset origins to geometry. Now we can set up a rigid body sim to place these pieces randomly. You can also do this manually. Simply select one piece and click on Rigid Body, then change the shape to Mesh and sensitivity to 0.01 meter. If you hit play, you'll notice it's laggy. This is mainly due to the grass being visible in the viewport, as well as substeps per frame for the RBD sim. Simply lower the substeps, increase solver iterations to maintain an accurate sim, and disable viewport display for the grass. Find the settings that work best for your scene, as more objects will reduce performance. Duplicate the grass plane and remove the particle sim. This will be the ground collision plane. Remember to disable viewport display within the particle settings menu. Next, copy the ground collision plane settings to the rocks. Select the firewood and copy its settings to the other pieces. Select all objects and apply transforms as well as set origins to geometry. You may need to adjust the firewood pieces to be more central so they don't fall outside the rocks. Once happy with the sim, set an end frame and bake it out. Select all firewood pieces, scroll to the final frame, and apply transformations. Scroll back to the first frame and remove rigid body world. Scroll through the timeline to confirm. Next, duplicate a few pieces and assemble the standing pieces or a teepee. The ground previously used as the collision can be used for the scattered stones with a new custom particle hair sim. To save time, I'll duplicate the grass plane instead. Organize the rocks and firewood into collections and apply the displace modifiers on the rocks, as these will be used as instances for the stones. Once set up, duplicate the grass plane and rename it to stones. Rename the grass plane to grass. With the viewport display disabled for the grass, select the stone plane and click on the two next to particle settings. This will create a separate sim, otherwise it'd be linked to the grass changing its settings too. Decrease the amount of particles, set viewport display amount to 100%, and set the children tab to none. We'll set this back to simple later on. Select the stone plane and hit tab for edit mode. Then tab again to go back to object mode. This will reset the viewport display for the particles. Back in the particle tab, set the stone plane to render as a collection. Then under instance collection, select the stone collection consisting of the rocks. Play around with the scale and randomness as well as other settings for more realism. You can also remove the vertex group for density. We don't want the rocks to be affected by any forces, so disable hair dynamics as well as any force field used in the scene. Now we'll add some wind to the scene. For better performance, lower viewport display amount for the grass, and set an end frame for the bake. Set up your framing and create a camera. Hit Ctrl-Alt-0 to snap the camera to your viewport display. Hit N for the side panel and select the View tab. Choose Camera to View to fine-tune your framing. Remember to turn it off when done. Setting the camera up now will make it easier to understand the scene and set up force fields. Create the wind force and aim it at an angle. Increase the noise and play around with the seed. This will make the grass look more natural as the strands sway back and forth due to the wind. As you can see, turning hair dynamics off results in an inaccurate sim. Turn it back on, lower viewport display amount, and lower the wind force for a slower and weaker effect. Make sure to set viewport display amount to 100% before baking, as shown here. Anything lower may result in inaccuracies. Once the sim has been baked, you can lower the amount again for better viewport performance. For more detail, you can duplicate the plane, remove the particle hair sim, and add some noisy displacement to mimic clumps of dirt or uneven terrain. Once set up, use a decimate modifier to reduce the number of polygons. This will increase performance for both the viewport and rendering. The clipping can be partially covered with the grass at 100% display amount when rendering. Now we can apply materials. Similar to the firewood, use a noise texture with some mapping, feed it into a color ramp, adjust the color tabs, and feed that into the base color. For fake displacement, feed the noise texture into a bump map and feed that into the normal. For the grass, you can always use a translucent BSDF for more realism. I use a simple sky texture with some adjustments made to the air, dust, and ozone. Play around with the background strength settings for the sunset effect. I use the grass material for the rocks, with changes made to the color tabs, as well as roughness and bump. Before setting up the fire sim, lower the viewport display amount for both the grass and stones, save your progress, and select all firewood pieces. Hit Ctrl J to join all pieces together. Duplicate one of the rocks and move it outside of its collection so it doesn't affect the stone particle sim as it's being instanced. Move it to the center of the campfire. With proportional editing, select some vertices and drag them out. This will generate some randomness. Lower the rock and keyframe its Z position. Scroll down the timeline, raise the rock to just below the top of the firewood, and keyframe its position again. If you play back the animation, the rock should simply move up the campfire. You can always add some noise to the movement as well as animate other axes too. This rock will act as a proximity to the firewood. Its location and shape will be used to paint some weight onto the firewood using dynamic paint. This will give the fire sim the growing flame effect. Select the firewood and set it as a canvas using dynamic paint. Make sure the format stays as vertex. Change the surface type to weight and check anti-aliasing. Select the rock and set it as a brush. Leave the settings as default. Select the firewood and make sure to also press the plus sign next to the vertex group under Output. Now, if you select the firewood, go into weight paint mode and play the animation, you should see some weight being painted on by the rock. You can either hide the rock or set it as bounds or wireframe in Object Viewport settings. Make sure to keep the rock visible when caching out the dynamic paint sim. You can also use the rock's animation for a growing glow effect on the firewood. Simply head into the shading panel, create a noise texture, give it some mapping, and set the texture coordinates as object. In the Object tab, select the proximity rock. Feed the noise texture into a color ramp. Adjust the color tabs for fire tones. Increase the emission strength to see the effect. Now create a gradient texture, set it to quadratic sphere, and connect it to mapping. Feed it into a math multiply node and connect that into emission strength. Play with the mapping and multiply node to center the gradient texture and display the glow effect. Once set up, if you play back the animation, you should see the glow gradually make its way up with the rock. The keyframes of the rock will control how close it matches to the actual fire sim. This can be adjusted with the simulation for a more accurate effect. Now we'll create the domain. Scale it up so no smoke or fire can be seen interacting against the domain boundaries or faces from the camera. Make sure to apply transforms and center the origin to geometry before clicking on Fluid in the Physics tab and setting the box as a domain. Select the firewood and bake out the dynamic paint. Make sure the proximity rock is visible in the viewport. Play back the animation to confirm. Now you can hide the rock again. Select the firewood and click Fluid. Make sure the fluid layer in the physics panel is sat below the dynamic paint layer. This is important as the dynamic paint's output will be used for the fire sim. Set the fluid as Flow. Select Fire plus Smoke. Increase sampling substeps to 2 and set flow behavior to Inflow. Set vertex group to DP weight or dynamic paint weight. Increase initial temperature to 1.5 and set density and fuel to 0.5. Under Flow Source, set surface emission to 1 and volume emission to 0.1. Now select the domain and set resolution division to 64 just to check if the sim is working. We'll change this to 256 later on. Set timescale to 0.1. I find the default value to appear too fast. For faster baking and better performance, lower time steps maximum to 2, enable adaptive domain and add 1 level of resolution. Change buoyancy density and heat to 0.25 and vorticity to 0.1. Enable dissolve and change the time to 20 with slow checked. Finally, enable noise, leave the settings as default, and under fire, change reaction speed to 0.25. Lower values will increase the flame height. Change flame smoke to 1.25 and vorticity to 0.1. Before baking, make sure to set up a cache location and change the end frame. Set sim type to all and enable resumability. Under field weights, change wind force to 0. Once happy, do a test bake to see if the sim is working. We're looking for the growing flame effect. If everything's working, we can now free the bake and change the resolution to 256. Add a turbulence force and center it to the campfire. This will give the fire some random movement to mimic flames. Change its strength to 0.25 and increase noise amount. You can do another test bake or continue for the final settings. As you can see with the current settings, the flames are too small and close to the firewood surface. Also keep in mind the viewport display won't look 100% like the final render. To view the final render in the viewport, we'll have to set up a volume shader for the fire sim. We'll use this test bake to create this. To save time, you can skip to the final material. Timestamp will be on display. Click on the domain and select a new shader. Give it a name. Remove the principled BSDF and create a principled volume. Make sure to feed it into volume in the material output and not surface. Create two attribute nodes. Name the top one heat, the bottom one density. Create two multiply math nodes. Drag the factor from each attribute and connect them to each tab on the multiply nodes as shown here. Create a color ramp and adjust the color tabs from black to white to gray. Feed it into emission strength. In rendered view, you should see some volume. Feed the top multiply node to the color ramp. Now you should see a more accurate volume material. If you connect the heat attribute directly to the color ramp, you'll see too much volume. The multiply node basically cleans out excess volume. Add another multiple math node to control the emission strength further. The bottom color ramp will be used for emission color. Feed the math node into it and adjust the color tabs for fire tones. Feed the color ramp into emission color. Play around with the color tabs and strength to fine-tune the flame's appearance. Create a noise texture with mapping and coordinates. Set it to 4D and multifractal. Under texture coordinates, choose the proximity rock as the object and connect the object node into mapping. Feed the noise texture into a color ramp. Feed that into a multiply math node, which connects to the density. For more smoke, drag the black color tab closer to the white tab on the right in the color ramp. Create a volume info node and connect density into a multiply node. Create a color ramp and drop it in between. This time move the white color tab closer to the black tab on the left. Feed the color ramp below into the top multiply node, which then feeds into the lower multiply node connecting to the density as shown here. I'll add another math node before the emission strength math node and connect the noise texture color ramp to the bottom value. This allows for more fine-tuning of the smoke's emission strength using the noise texture. As you can see, playing with the final node before emission strength gives a stronger flame appearance. With the test bake, we can see when the fire appears in the camera view and in the timeline, count 5 to 10 frames before any smoke or fire appears, and set that as your start frame. This can speed up bake and render times. Here you can see the final volume shader material. I'll make a few more tweaks using blackbody tint and intensity, which will give the campfire a stronger, heat-radiating appearance. Connect the math node, which feeds into emission strength, also into blackbody intensity. Take the node before emission color and also feed it into blackbody tint. You may also use a custom color. To improve performance and clarity in the rendered viewport, click on the camera and head into its Viewport Display tab. Enable Pass Part Out and set it to 1. This will black out anything outside the camera view. Here you can get a glimpse of my viewport and render settings. Under the Volume tab, the step rate controls how much detail your volume will have. A lower step rate means more detail, but will slow down your viewport and rendering. For test renders and viewport performance, I like to keep this number between 16 and 64. For high-res renders, I use 0.5. Under light paths, you'll see a volume tab set to 0 by default. Increasing this number will allow for more light rays and bounces for volumetrics. I'll keep this 0 as setting it to just 1. doubles render times most of the time. Enable denoise and choose your denoiser. I find optics to be faster but less accurate, and OpenImage denoiser to be higher quality but may take a few seconds longer, which can add up over time. I'll also set the look and color management to medium-high contrast to bring out the flames and glowing firewood. For a test render, I'll set the resolution to 720p and export using PNGs. Make sure to set an output directory for your saved frames. You can use Blender's built-in video editor to sequence the frames and export an animation. Before rendering, I'll generate some embers, create an icosphere and set subdivisions to 1, create a plane, and scale it down to become a thin rectangle. This will give the embers a random and realistic appearance. Select both objects, apply transforms, and center origins to geometry. Then click M and move them to a new collection. Name it Embers. Duplicate one of the rocks. Remember to move it to Scene Collection so it doesn't get instanced on the stone's plane. Scale it down and center it in the campfire. Correct transforms and origins. Give the rock an emitter particle system, increase particle amount, and set it to render as a collection. Select to instance the Ember collection. Rename the rock to Ember Source. Under Field Weights, change Wind to 0.25 and turn off Gravity. Play the animation to check the particle movement. For better performance, disable the Fire Sim from the Viewport. Select the Ember source and hit play. As you can see, the particles are moving too fast. We can slow them down by changing some settings and adding a force field. Under the Physics tab, increase Brownian to 0.25 and change mass to 10 kilograms. Under Velocity, change normal to 0.1 meters per second, change randomize to 0.1. Playing the animation now, you will see the particles move randomly and slightly slower. Under the emission settings, change the frame start and end number to match the Fire Sim. I set the start frame to 60 and lifetime to 270 later on. You can also play around with the scale and randomness for a more realistic effect. Now we'll create a vortex force field to align and slow down the particles, as well as introduce more randomness with noise and induce rotation. Zooming in, you can see the particles move slower and more randomly. Slowly increase the scale until you're happy with the appearance. For Ember materials, I simply used an emission shader with a strength of 5 and set different colors for the icosphere and plane. Play the animation to check the material. You may need to lower your sky background strength for more visibility depending on the scale. You can see some particles are moving below the campfire. To fix this, head over to the Velocity tab and set the Z value to 0.25. Check the rendered viewport with the Ember source selected. Here you can make clearer adjustments. Once happy with the scene, make sure to disable Vortex Force Field for the domain. As you can see, not doing so results in a stale and stationary simulation. Before baking the final simulation, you can do another test bake. As I'm going for the final sim, I'll double check the domain settings as well as any other object with physics systems applied. It helps to bake any dynamic paint or particle simulation you may have running simultaneously, as not doing so results in the sims being calculated during rendering, which slows down performance. Also, make sure to bake them before the fire sim itself. If you're rendering out the final baked campfire simulation, it won't hurt to render a test animation at either 480p, which is 852 by 480, or 720p, which is 1280 by 720. As a test render, keep the volume step rate and render sampling low. If you're happy with the animation and ready to render out in full res, make sure to change your step rate, sampling, and resolution settings, as well as save before rendering. If everything's baked, it may also help to save and close Blender and any other app you have running. This clears out some memory or RAM and allows for better performance from your PC when you next open Blender and start rendering. That being said, I hope you enjoyed this tutorial and are able to apply it to other projects. Hopefully you like and subscribe. If you have any questions, feel free to leave a comment. See you in the next one. Take care.